All right, hello everybody. I'm going to go over the Unit 13 review sheet in case you needed any help with any of the questions that we didn't have a chance to get to in class. So question number 1 says, which figure can have the same cross-section as a sphere? So a cross-section is when you slice through, almost like picture you're cutting it with a knife, and then you're turning the shape to see what two-dimensional figure you can see. So a sphere, since it's circular, the cross-section of a sphere, if you slice through, would be a circle. So you want to know which one of these figures, if you slice through it, would also have a circle. So, well, which one has a circular base? The cone. So that's the only other figure listed here that if you slice through it, you would see a circle. All right, question number 2. A rectangular prism has a length of 25, a width of 9, and a height of 12. All right, so let's start with that one. Now, we know that volume is big B times H for a prism, but big B is the area of the base. And how do you find the area of a rectangle? Length times width. So this is really just going to be length times width times height. So for this first prism, the volume is going to be 25 times 9 times 12. Which gives us 2,700. Now it's saying a second prism has a square base with a side of 15. If the volumes are equal, what is the height of the second prism? So the second prism is going to be 2,700 equals, now since it's a square, the length and the width are the same, and we're trying to figure out the height. Well, 15 times 15 is 225. So I'm going to divide both sides by 225. And we get 12 for our height. All right, number 3 and number 4 all have to do with the idea that the perimeters or the sides are in the ratio A to B. Areas are in the ratio A squared to B squared. And volume is in the ratio A cubed to B cubed. So we talked about this in our similar triangle unit. So what they are giving us right here is they're giving us the perimeters is in a 2 to 9 ratio. So they're giving us A to B. What they want is they want the ratio of the areas. So they want A squared and B squared. So we're just going to do 2 squared to 9 squared. So that would be a 4 to 81 ratio. The next one, if the ratio of the surface area of two similar cylinders is 16 to 25, so I'm just going to write it bigger. So 16 to 25, that's an area ratio because it said surface area. So what we have to do is we have to figure out the A and the B. So we're going to need to take the square root of those numbers. And that gives us a 4 to 5 ratio for the sides. But what do they really want? Did they want the ratio of the sides? No, they wanted the ratio of the volumes. So that's A cubed to B cubed. So now I'm going to take those numbers and I'm going to cube them. So 4 cubed is 64 and 5 cubed is 125. So the volumes would be in a 64 to 125 ratio. All right, number 5, a packing carton in the shape of a triangular prism. So I'm going to highlight that. Now you can go to your reference sheet. The formula for prism volume equals big B times H. Because this time, remember, big B is the area of the base, because our base isn't a rectangle, so we can't just do length times width times height. This time our base is a triangle. So I'm going to have to figure out the area of that triangle. So for a triangle, the area is 1/2 the base times the height. So it's going to be 1/2 6 times 4. And that will give you 12. So now if I want the volume of my prism, big B was 12. And now the height, we're not talking about the height of that triangular base, we're talking about the height of the prism. And the height of the prism goes from one base to the second base. Right, so these are my bases, these triangles. So the height connects those two bases, so that's the 10. Which means that our volume is 120. And everything was in inches, so volume will be inches cubed. All right, question number 6. A right circular cone is shown at the right. The radius of the cone is 5 meters, and the slant height is 13 meters. Anytime you see a question with slant height in it, that lets you know that you're going to have to use Pythagorean theorem. Because we don't know the actual height of the cone yet. So over here, we have this right triangle. And I'm going to redraw it. So they're saying the slant height is the 13, the radius is the 5, but we need to know the height of that cone. So we're going to do a squared plus b squared equals c squared. The only important thing is that c is the hypotenuse, which is across from the right angle. So I'm going to say h squared plus 5 squared equals 13 squared. I'm going to subtract that 5 squared to the other side. And 13 squared minus 5 squared is 144. I'm going to take the square root of both sides. So h equals 12. All right, so we found the height. The height of that cone is 12. So now we can figure out the volume. And same thing, you're going to go to your reference sheet to look up the volume formula for a cone. And volume equals 1/3 pi r squared h. So it's going to be 1/3 pi times the radius squared, so 5 squared, times the height, which we found out was 12. Now this particular question does not tell us where to round to. So since they didn't tell us to round, we're going to leave it in terms of pi. So all I'm going to do is I'm going to type in the 1/3 times the 5 squared times the 12. I'm leaving out the pi. And that gives me 100. So 100 pi will be my answer. So if they don't tell you where to round, then don't round, leave it in terms of pi. If it said to the nearest tenth or nearest cubic meter, then you could round it and type in the pi. All right, so number 7, we have a composite figure over here. So the diagram at the right shows a right circular cone and a hemisphere. Find the volume of this solid. So I'm going to start with the volume of the cone. So the formula for that on the reference sheet, 1/3 pi r squared h. Now the radius of this cone, they gave us the diameter of 6, so the radius is 3. So it's going to equal 1/3 pi times 3 squared times the height, which was 8. Once again, they didn't tell us to round, So I'm going to leave out that pi. Whoops. See how my 8's still in the exponent? I got to make sure that I arrow out of there and then do times 8. So we get 24 pi. So that's the volume of the cone. Now I need the volume of the hemisphere. So if you look up on the reference sheet the formula for the volume of a sphere, it's 4/3 pi r cubed. But since we have a hemisphere, we only want half of that, so I'm going to do 0.5 times that. And our radius was 3, so it'd be 3 cubed. So remember, I'm typing in everything but the pi, because they didn't tell me to round. So 0.5 times 4/3 times 3 cubed. And that gives me 18, so it's going to be 18 pi. Now the total volume is going to be if I add those two together. So it's going to be 24 pi plus 18 pi. And 24 plus 18 is 42. So 42 pi. So that is my total volume. All right, question number 8. Sue believes that the two cylinders shown in the diagram below have equal volumes. Is Sue correct? Explain why. Well, we have something called Cavalieri's principle, and that lets us know that as long as your figure has equal bases, like the area of the bases are the same and the heights are the same, then you would have the same volume. Because if you notice, both of these are cylinders, right? So the volume, it's still big B times H, if you want to think area of the base times the height. It's just that the area of the base is pi r squared. So in the one on the left, they give you the radius is 5 meters. The one on the right, they're giving you the diameter is 10. So that means 5 meters is your radius. So both of those circles have a radius of 5. So they would have the exact same area. Now we just want to look at the heights. Is the height going to be the same? Because I know the pi r squared part's going to be the same. Well, the height of this cylinder is right here. And the height of this cylinder is also 11.5 because the height measures the distance from one base to the other. This number 12 here, that's the slant height. And the slant height isn't part of our formula. So we actually didn't even really need to know that. So I'm going to say she believes that the two cylinders have equal volumes. So is Sue correct? Yes, Sue is correct. Since the cylinders have equal bases and equal heights, they will have equal volumes. And that is called, if you ever wanted to use the name in your reason, that's called Cavalieri's principle. But you can get away with not putting the name in your reason, just explaining what the principle means. All right, number 9, the greenhouse pictured below can be modeled as a rectangular prism with a half cylinder on top. The rectangular prism is 20 feet wide, 12 feet high, and 45 feet long. The half cylinder has a diameter of 20 feet. To the nearest cubic foot, what is the volume of the greenhouse? So this time they do want us to round, but remember we are going to round on our final step. So even if you type it into the calculator with the pi earlier, we're going to be using the full decimal. All right, so let's start with the rectangular prism. So the volume of the prism, it's a rectangular prism, so it's going to be length times width times height. So it's going to be 12 times 20 times 25. And we get 6,000. All right, then the other figure was a half cylinder. So the cylinder formula was pi r squared h, but we only want half of that. So we're going to do 0.5 times that. So it's going to be 0.5 pi times the radius squared, and the radius of that cylinder would only be 10 because the diameter was 20. So that'd be 10 squared times the height. And remember, the height goes from one base to the second base. So here's like the first base, the second base of my cylinder would be back here. So the height is the 45, the height of that cylinder, because it's connecting the front to the back. So I have a feeling most of you are going to type this whole thing into your calculator, and that's okay. Now, if you do that, we're not going to round to the last step. So I'm going to write down the decimal, and I'm going to write down a few numbers after, and I'm going to write dot, 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 so we know that I didn't round it yet. I'm rounding on the last step. So now for the total volume, I'm going to be adding these two numbers together. But remember, I'm using, in the calculator, I'm going to use the full decimal. So the decimal's already in there, so I can just hit plus 6,000, so it used everything. And I get 13,068.58. So now we can round to what they asked. Nearest cubic foot, so that's a whole number. The next number is a 5, so we're going to bump that up. So our total volume is going to be 13,069. Right? And that would be cubic feet, because it's feet times feet times feet. All right, question number 10. What is the volume of the 3D solid formed when the triangle shown at the right is rotated about the y-axis? So if you take this figure and this triangle and you spin it around that axis, well, anytime you spin something, on the bottom, it's going to be making a circle. So if we have triangular sides and a circular bottom, the figure that we just created is a cone. So we want the volume of that cone. Remember, don't forget to look at that reference sheet because the formula is there for you. 1/3 pi r squared h. Now the radius of this cone would be 1, 2, 3, 4. And the height of this cone, 1, 2, 3, 4, 5, 6. So it's going to equal 1/3 pi times 4 squared times 6. Once again, they didn't tell us where to round. So when they don't tell you where to round, you leave out the pi. And you get 32, so it'll be 32 pi. All right, number 11. A hemispherical tank is filled with water and has a diameter of 10 feet. If water weighs 62.4 pounds per cubic foot, what is the total weight of the water in the tank to the nearest pound? So what they just did here is they gave us a density. Right, it's pounds per cubic foot. So if we want to figure out how much it weighs, it's equal to the volume times the density. So we're going to basically figure out our volume, and then we're going to multiply our answer by 62.4 pounds to figure out how much this tank weighs. Right? And they said it was a hemisphere. It kind of looks like a dome. And they said that the diameter of that hemisphere was 10. So if the diameter is 10, then that means our radius is 5. Okay, so we're going to look up the volume formula for a sphere is on the reference sheet. That's 4/3 pi r cubed. We only want a hemisphere, so we're going to multiply that by 0.5. So it's going to be 0.5 times 4/3 times pi times 5 to the third. So this time I typed in the pi because we are eventually going to round it. All right, so that's my volume. So I want to take that volume and I want to multiply it by the density. So I'm going to take that number and I'm going to do, so 261.7993 ... times that density, which was 62.4 pounds per cubic foot. So in the calculator, I'm just going to hit times 62.4. And that gives me 16,336.2. They said nearest pound, so I'm going to leave it as 16,336 pounds. So that's how much that tank would weigh if it was filled with that much water. Right, number 12, a pharmacist is filling medicine capsules. The capsules are cylinders with half spheres on each end. Okay, so let's sort of sketch that out. So we have a cylinder. But then we have a half sphere on this end and a half sphere on that end. So basically, we have a cylinder and we have one sphere because I have a half sphere on the top and a half sphere on the bottom. So that combines to make one full sphere. So I need to figure out the volume of the cylinder. And I'm going to use pi r squared h for that. And then I'm going to need to figure out the volume of the sphere. And I don't have to worry about hemispheres because 2 hemispheres make one full sphere. And that formula is 4/3 pi r cubed. All right, so let's do those calculations first. So the length of the cylinder is 12 millimeters. So that's going to be like the height of it. So it's going to go from base to base. And the radius is 2. All right, so let's figure out the volume of our cylinder first. So it's going to be pi times 2 squared times 12. Now we could leave it in terms of pi or we can calculate it. I have a feeling most of you are going to calculate the full decimal, so I'm going to do it that way also. And that would give us 150.7964 ... For the sphere, 4/3 pi times 2 cubed. And that gives us 33.5103. And then for our total, we're going to add those together. Now I'm using the full decimal, so I'm going to hit plus, so that's going to use my last answer. And then I'm going to go up and I'm going to highlight. So I'm just hitting the up arrow to highlight that other volume that we got. So it brings down the whole decimal. Enter, and I get 184. And I'm still This one says round your answer to the nearest tenth of a cubic meter. 184.3. All right, part B says using your answer from part A. If they did not say that, then in this second part, you'd be using the full decimal again. So you would have had a dot, dot, dot over here, and you'd be using the full decimal. Because they said using your answer from part A, we don't have to worry about that. So we're going to do 184.3. So that is the volume in cubic millimeters. And they're saying that the medication costs 79 cents per cubic millimeter. So we're going to multiply that by 79 cents. That's going to tell you how much the medicine costs for one capsule. But then it says we have 100 capsules that we're filling. So times 100. And like I said, if they did not tell you to use your answer from part A, we would just be using the answer that's stored in the calculator right now. And this, we'd get this as our answer. Now, because they said to use our answer from part A, I'm using the 184.3 times 0.79 times 100. And if you see, you get a different number. And since it's talking about money, we would want to round it to the nearest cents. So this would be $14,559.70. But the more accurate answer is actually the one that we got when we used the full decimal. So it's really going to cost you $14,560.23. So when they don't tell you to like use your answer from the part above, you're using that full decimal, and you're going to get something that's really, really close. Like we're only about 53 cents off. But think about it. If you're a pharmacist and you have a business, do you want every single customer shortchanging you 53 cents? No, you want to use the most accurate decimal. All right, I hope that helped. And good luck on your test, everybody.